Assalamu alaikum. How are you, students? Hope you all are fine. I am also fine. So, after the Eid vacation, welcome back to my physics class. Dear students of standard 9, me Mafruafil Shati. Today, I am going to explain some topics from chapter 6 of your physics book. The name of the chapter is Effect of Heat on Matter, and today's topics are coefficient of superficial expansion, coefficient of volumetric expansion. Superficial expansion and coefficient of superficial expansion. By seeing the picture here, I think you can understand what I am going to explain. Superficial means the expansion in area. The area of a solid is increased with the increase of temperature. It is called superficial expansion. Look, here the initial area, surface area of the solid matter is A1. And when the temperature is increased to θ2, the final surface area is A2. So increase in temperature is θ2 minus θ1. And increase in surface area is A2 minus A1. So if the coefficient of superficial expansion is denoted by beta, by the symbol beta, then we can write superficial expansion beta equal to A2 minus A1 divided by A1 into θ2 minus θ1. That means increase in area divided by initial area into increase in temperature. In this way, we have already calculated the coefficient of linear expansion, what I have shown you in the first content related to this chapter. So, dear students, in the above equation, if we put the value of surface area A1 equal to 1 square meter, suppose we consider the surface area A1 equal to 1 square meter, that means which was the initial surface area, and the increase in temperature θ2 minus θ1 is 1 Kelvin considered, then what will happen? If we put the value in this equation, it becomes beta equal to A2 minus A1, that is equal to increase in surface area. So from here, from this equation beta equal to A2 minus A1, you can define beta. So the increase in surface area of 1 square meter, surface area of a solid for the rise of 1 Kelvin temperature is called coefficient of superficial expansion of the material of the solid, and its unit is per Kelvin. Look here, A2 minus A1 its unit is meter square, A1 its unit also meter square, θ2 minus θ1 its unit is Kelvin. So it becomes per Kelvin because meter square and meter square will be cut, cancel out each other. Then what will depend? What will remain here? 1 by Kelvin, that means Kelvin inverse 1. Dear students, I have already told you no need to memorize any definition. You just try to understand and you just try to feel. So look here, beta equal to A2 minus A1. That means increase in surface area. From this you can define beta. So this you got, in which case when the original surface area or initial surface area is 1 square meter and the increase in temperature is 1 Kelvin, that time what increase in area you will get, that is called coefficient of superficial expansion beta. I think you understood. Now I will show you how to calculate volume expansion, coefficient of volume expansion. Look here, V1 is the initial volume of any solid substance at θ1 temperature, and after giving heat, when its temperature is raised to θ2, then its volume becomes V2. So here, volume expansion means expansion in volume. The volume of a solid substance increases if its temperature is increased. It is called volume expansion. So now we will calculate the coefficient of volume expansion. Let the initial volume of a substance is maybe V1 and initial temperature be theta 1, and when the temperature is raised to theta 2, its volume becomes V2 after being increased. So increase in volume equal to V2 minus V1, and increase in temperature is equal to theta 2 minus theta 1. So the coefficient of volume expansion now I will calculate, and if you denote it by gamma, then gamma equal to this, that means V2 minus V1 divided by V1 into theta 2 minus theta 1. That means increase in volume divided by initial volume into increase in temperature, and its unit also will be per Kelvin like the previous one. So now you can define the coefficient of volume expansion. If the initial volume is 1 cubic meter, that means whose length is 1, length, breadth and height all are 1, then its volume will be 1 cubic meter. And increase in temperature is 1 Kelvin. If we put the value in this equation, it becomes what? Gamma equal to V2 minus V1. That is increase in volume. Therefore, the increase in volume of a solid of the volume 1 cubic meter for a rise of temperature 1 Kelvin is called the coefficient of volume expansion of the material of the solid. Dear students, there is a relation among alpha, beta and gamma, and you have to memorize it. That is gamma equal to 3 alpha and beta equal to 2 alpha. Okay. Because for solving MCQ and also in case of creative, this relation is very much important. So you must remember it. And from here you can also write alpha equal to gamma by 3 or alpha equal to beta by 2. Now I will explain expansion of liquid. So liquids have no definite length or area, but it has definite volume. You knew it from your very junior class. If the temperature is increased, its volume increases. So the expansion of liquid means what? The expansion in volume of the liquid. The rates of increase in volume of all the liquids are not same. Okay. Different liquids having the same volume expand differently for the same rise of temperature, and here this we will show by doing one experiment. For that experiment we need these such of things: a number of long naked glass bulbs of equal volume and size are taken. Equal volume of water, alcohol, kerosene, ether, etc. are taken in these bulbs. Look, here 4 bulbs of equal volume and equal size are taken, which are containing water, ether, benzene and alcohol. Okay, and these water, ether, alcohol, benzene, all of the same volume we have taken in the bulbs. So you know, liquid level first falls down when flask plunged into hot water. Okay, so we will take a large vessel which contain water of room temperature, and we will put the bulbs, those 4 bulbs vertically. We will place the bulbs vertically inside this larger vessel which contain water of room temperature, and we will mark the level of the volume in the stem. They will be of the same height. Now we will pour some hot water in the larger vessel. Okay, then what will happen? When we pour some hot water into the vessel, then after some time the bulbs will attain a higher temperature, and it will be seen in the stem, the stem of the bulbs. The upper level of different liquids are not at the same height, rather their heights are different. Look, after pouring hot water, when the temperature will be increased, then we will see, when the temperature will be increased, then what happens? At first the container will take in the heat, and then the liquid will take in the heat. As a result, the volume of the liquid will be increased, and we will see the increase of the volume of liquid in this stem. Those are not at the same height, rather they are at the different height. So it is understood that the volumes of different liquids of same volume, we have taken different liquids but of same volume in this container, but they expand differently for a definite increase of temperature. Okay. In the next topic, I will explain real and apparent expansion of liquid. Liquid always has to be heated, keeping it in a container. The liquid as well as the container expand when heat is applied. So the expansion of the liquid observed by us is not the real expansion, but it is an apparent expansion. There are two types of expansion of liquid: real expansion and apparent expansion. At first, I will explain real expansion. Dear students, here you are seeing in the bulb, we have taken some liquid. At first, we will take the liquid up to the level A. Okay. I will explain this figure later on. So before explaining this, I will explain real expansion. If it had been possible to heat a liquid without keeping it in a vessel, then the real expansion of the liquid that would be obtained is called real expansion of the liquid. But heating a liquid without a container is not possible. So considering the expansion of the container, the actual expansion of the liquid that is obtained is called real expansion, and it is denoted by VR. Now let's know what is apparent expansion. Apparent expansion. The expansion of liquid apparently observed without considering the expansion of the container is called the apparent expansion of liquid. It is denoted by VA. Look here, I have already told you the liquid at first taken up to the level A, and if we apply heat from the bottom of the container or the bulb, then what will happen? At first, the bulb is made of glass, so at first the container or the bulb which is made of glass will receive the heat and it will be expanded. As a result, the level of the liquid will go down, okay, and it will reach to the level B. Then the liquid that is contained in this container will receive the heat. So at first the container will receive the heat, then the liquid will receive the heat, and the expansion of the liquid will be more than that of the solid. So the liquid will be expanded and it will reach to the level C. So apparently it seems the liquid is raised from A to C. The liquid level is raised from A to C. So this is apparent expansion. That means AC is the apparent expansion. But real expansion is what? Expansion of the liquid and expansion of the container. So we can't ignore the expansion of the container for calculating the real expansion, because liquid cannot be heated up without keeping it in a container. So BC is the real expansion. So here, therefore, CA is the apparent expansion and CB is the real expansion. So AB is what? Expansion of the container. AB indicates the expansion of the container. So from figure it is observed that CB equal to CA plus AB, or real expansion equal to apparent expansion plus expansion of the container. So now we can write VR equal to VA plus VG. That means real expansion equal to expansion, apparent expansion plus expansion of the container. Here we consider the container is made of glass, so we write here VG, and VA for apparent, VR for real. Now I will show this experiment by using a video which will make you more clear. So let's watch. So let's look. Here, colored liquid is taken in a container. Cork with a narrow tube is fitted to it. The initial level is V1. The container with liquid is heated. Here, by using a Bunsen burner, the liquid is heated. So, what will happen? The container expands first and the level drops to V2. Then the liquid will receive the heat in the container. Later the liquid expands, raising the level to V3. So apparent increase in volume is what? V3 minus V1. And real expansion, real increase in volume is V3 minus V2. Now I will explain expansion of gases. So here you are seeing the gaseous substance is kept in a container, tightly fitted a piston over there. It is very interesting in case of gas because neither does it have a definite shape nor a definite volume. A gas takes the whole volume of the container where it is kept in. So we will calculate the coefficient of expansion of gaseous substance. For calculating it, we need to know the ideal gas equation. Ideal gas equation, this equation is the relation between pressure, volume and temperature. Okay, this is ideal. This equation is called ideal gas equation. P equal to nRT, where P is the pressure, V is the volume, N is the number of N is the amount of gas that is measured in mole, amount of substance. R is a constant. R is a constant whose value is 8.314 joule per Kelvin mole, and T is the temperature in Kelvin scale. Here this R is also known as Boltzmann constant. So now I will calculate the coefficient of volume expansion of gaseous substance. Now we can find the coefficient of expansion of a gas at a certain pressure if the volume of a gas is V1 at T1 and the volume is V2 at temperature T2. then the coefficient of volume expansion beta P equal to V2 minus V1 divided by V1 into V2 minus V1 by V1 into T2 minus T1. This V1 can be taken here also. Okay, no problem. Same thing. So, ideal gas equation what? PV equal to nRT, and I have told you at T1 temperature the volume is V1 and at T2 temperature the volume is V2. But if we keep the pressure constant, pressure remains P, then what happened? PV1 equal to nRT1 equation 2 and PV2 equal to nRT2 equation 3. Now we will subtract equation 2 from equation 3, then we will get this equation P into V2 minus V1. Look, from here we will subtract this one, then P common, V2 minus V1 equal to, here nR common, T2 minus T1. This is equation 4. Now we will divide equation 4 by equation 2. Okay, then what will happen? P V2 minus V1 divided by P V1, then P will be cancelled out, then what will remain? V2 minus V1 by V1, and here NR will be cancelled out, so T2 minus T1 by T1 will remain. So from here this T2 minus T1 we can take this portion. Okay, but this is equal to beta P, that is the coefficient of volume expansion. Okay, the coefficient of volume expansion is indicated by beta P, coefficient of volume expansion of gas indicated by beta P. So beta P equal to 1 by T1. Therefore, you can see that the coefficient of expansion of gas are not constant at all. It is reciprocal to the temperature T1, that means initial temperature. It is reciprocal to the initial temperature, that is inversely proportional. The less the temperature, the more the expansion. The more the temperature, the less the expansion. Dear students, here I have given the answer of two questions. That is, the coefficient of superficial expansion of copper is 33.4 into 10 to the minus 6 per Kelvin. What does it mean? Frequently, this type of question comes into SSC examination as a B number question, which carries 2 marks. So, the coefficient of superficial expansion of copper is this. It means that if the temperature of a copper body is increased through 1 Kelvin, then the increase in surface area of copper is 33.4 into 10 to the power minus 6 per square meter. The coefficient of volume expansion of copper is 50.1 into 10 to the power minus 6 per Kelvin. What does it mean? The coefficient of volume expansion of copper is 50.1 into 10 to the minus 6 per Kelvin. It means if the temperature of the copper body with a volume of 1 cubic meter is raised through 1 Kelvin, then its volume will increase by 50.1. Dear student, here will be a multiplication sign. Sorry for that mistake. 50.1 into 10 to the power minus 6 per cubic meter. And you will try to memorize this answer, because I have already told you it can come as your B number question, that is realization based question. So today I want to finish my lecture. In the next content I will show you some mathematical problem. So till then, stay safe, stay strong. There is a moral for you: success is the sum of small efforts repeated day in and day out. So goodbye everybody.